Hello team, today's challenge is Connect 3, where we're given an array of the game board, I guess. Connect 4 is actually vertical, so I'm not sure if we call it a board, but we have red, yellow, and empty spots on that game board. And we need to determine who wins. So in the first case, we have 3Rs right here, which means that we return red along with their winning positions, okay? The positions that they use to win. When you think about it, this the game board could be any size. So it could expand out to, say, Connect 4, right? Which is a 6 by 7 grid, right? Or anything, really. And we need to test against that. The other thing that's interesting about Connect 3, at least, is that it's really just a fancy version of tic-tac-toe. And we have done that before. We've done that right over here back on January 10th, right, where we had that. And because tic-tac-toe is a fixed board of 3 by 3, we were able to calculate all of our solutions, which means that we were able to iterate through those solutions and get this done. Well, with a matrix, we need a little bit more. And I've said it before in other videos where anytime we have a matrix, we need to deal with the rows and the columns. And so we're in it for 2 loops, right? So we're going to use something very similar to this code, but we're also going to wrap it up in those extra loops so that we can send in any size game board and it should just work. Okay. But that's what we're going for today, which means that we are over here. Okay. The first bit is, how are we doing this? Now with this, my preferred way is just to sort out directions from top left. We go left to right, top to bottom, and we take care of all that stuff. I just realized that right is wrong. This should be 0 and this should be 1. Brilliant. So we can go right, we can go down, we can go diagonally right or diagonally left, right? And those are our directions. So this could be named differently. And with this, we can use math to get our extra positions. So whereas maybe we go right by 1, well, we can go right by 2 just by multiplying both these by 2, right? 2 times 0 is 0, so that stays the same. 2 times 1 is 2, which gives us our next position, okay? With all that, we can get into it. So we are into those 2 loops, which is let row equals 0, just like this. And row is less than matrix dot length. Brilliant. Row plus plus. Sending it down, we're going to bring this down, punch it in a little bit, grabbing these, going column, okay, column, and then matrix row, and closing it out so that the editor still likes us, okay? These are our 2 things. We go through the rows, we go through the columns. Inside of here, we're going to get the current position, because the hope, the goal is for the current position to be the winner. And if it is, we return something. If it isn't, we return an empty array, okay? So inside of here, we're going to get that current position right away, which is const current equals matrix, row, and column, okay? If current is an empty string, then we should skip it. We aren't counting empty strings. In fact, we aren't counting anything falsy. There's a slight danger here if you're using 1s and 0s, where this bit of code could fail you, right? Because 0 is falsy. But if there is no current, okay, then just continue, right? We aren't backing out of the whole function. We're just backing out of this loop, right? We're going to the next step. So right there, we do that. And then we're in it for that solution loop, okay, which is not an if, it is a for. I don't know why I did it that way. But let the direction of the row and the direction of the column, or deltas, if you will, of directions, just like this, and we build some stuff out, okay? First, we have the first row and first column, just like this. That's going to be equal to what? Well, it's going to be equal to row plus the direction of the row and column plus the direction of the column. Excellent. Okay, we need this for the second position as well, so let's go and grab that. Right here, we'll change this to second position, and this D multiple times. Excellent. we times that by 2, okay? So with these two positions, we can do our final steps. We're in it, right? So we have our if, just like the tic-tac-toe code. We test current equal to matrix FR and FC. Now, because we are moving the position, there's a chance that we could move off the board. We could be outside of the grid, right? And so one of these could be undefined. If the second one is undefined, not a problem, because it just returns undefined. But if the first one is undefined, then we get errors in our console because it's trying to find this value off of something that is undefined, right? We've seen that error before, and we don't like it. So let's use some optional chaining here to get that done. We're going to do the same thing for this, which is second, and it's screaming because I didn't do the ampersand, okay? Oh, I didn't, wow, look at me go. Just jumping ahead, but that's okay. This should also be triple equals. I'm not sure why I did single equals. It's, I'm trying to race along. So there it is, okay? But with that, we can return. And we return what? Well, we return the current value. And then we return an array with row and column, just like this. And we return an array with the first position, so first row and first column, and an array with second row and second column, okay? And with all that, that should do it, okay? The problem is that it is very basic and very coded to this 3-position win, okay? We do connect 3, but us having to do this, there's a little bit of duplication in here that I don't like. So I feel like we should probably try some different things here, okay? If you want speed, this is the fastest way. But if you want flexibility for the future, then we need to do something else. And that something else is coords. Coords equals new array with 3, okay? So what we're doing is we are allocating 3 spots in memory so that we can fill them with something, okay? On that, we go down here and we set it up where it is another loop, okay? So let I equal 0 and I is less than 3 and I plus plus, okay? With that, we go coords I, okay? We do a direct reassignment because those items, those slots are already available. So no pushing, it's already done, which makes this fast, right? If we tried to do array.from, it would be super, super slow, like thousands of ops per second. This gets us hundreds of thousands of ops per second. So way faster, way better, which means that we just get it done. What are we doing in here? Well, we're doing all of this. So we bring this down and we change these 2's to I, okay? There's a small catch in here where we're actually recreating row and column, but that's okay, right? It's one extra thing. We could reduce this down and do some stuff, but it's not going to hurt anything, okay? It's only one extra loop, so we'll just let it ride. And then inside of here, instead of all this, we use an every. So coords.every, and inside of here, we get the row and the column. Be sure that those are in square brackets. We're destructuring that, okay? And then right here, we're going to test this, right? So we bring this down, paste it in. This is going to be the row and the column, just like this, which means that now we have everything we need except to clean this up and pass in coords, okay? But coords, they want it as a single level. They don't want a coords array. They want each of those individual coords in there. So we need to spread this out, and it works, okay? In fact, we could go further. So as an example, we have, we can clean this up a little bit just to make it a little bit neater, but we've hard-coded the number 3 in here, right? What if we took this? I'm going to copy this and make a new function. Right here, it's going to scream at me for a second, but that's okay. This is going to be connect n, okay? And then we're going to set n, oh, that should be a comma, sorry, n equal to 4, because it's connect 4, okay? If you want to set it to connect 3, you absolutely can, but I'm going to do connect 4 under the assumption that that is the quintessential connect game. Okay. So with n in here, we can go n here and we can go n here. Brilliant. And then what we do is we take connect n and bring it down here. So we return connect n, we toss in our matrix and we send in 3 and it should still work. Why did I do that? Right? We're getting to the end. Everything is working and working quite well. So why this extra bit? Well, because now we can actually take this bit of code here back to our tic-tac-toe challenge. Check this out, okay? I'm going to copy that. I'm going to take it over here. We are going to comment out everything. We'll come back to it in a second. Paste this down. That's our helper code. We still need parts of this function, so we will grab it, copy it, pasting it in, and getting the parts that we need, which are really just the strings, okay? So we get rid of all of this and then highlight this, okay? Same sort of thing. We're going to get const something, which is the winner, right? Because the winner is the first element off that array. And that's going to be on what? Well, it's going to be connect n. We toss in our board this time, and we still set it to 3 because it's a 3x3 grid, right? Now, if we have a winner, then return the winner, right? Which is not board A, it is winner. Otherwise, return draw, and it still works. So the point here, this bit of code is always going to be slower than this bit of code because we have all those extra loops in there, right? For the different matrix sizes. But with this, if we were doing some sort of games setup, right? And we wanted to do tic-tac-toe and connect 3 or connect 4 or connect 15, whatever you're planning there, you could probably even use this for things like Battleship, I'm guessing, but maybe, right? Then we have it, right? We already have a single chunk of code that can be used in multiple places. So bringing it all home, right? We set up our data and our data relies on a direction, right? And we really only need to test in one of these directions. We don't test right and left. We only need to test right because that by default already tests left, right? If that makes sense. Same with down. We don't need to test up because we've already tested down. So with these, we set up for our matrix, our rows and our columns. We get a little bit of information out, and then we iterate over our directions. And with that, we need to create a little bit of information in here. Could we refine it? Maybe, right? It's already pretty good. And then we test to make sure that everything equals our current value. And if it does, then we return the current value with our coordinates, right? And send it out the door. So lots and lots of stuff in there, but it works great. And it works with that old tic-tac-toe challenge too. So we're able to share more code, which makes our maintenance cycles easier, easier testing, easier time for the developer. Did you think so? Right? Do you think so? Do you like it? Do you hate it? Did you go a different way? Let me know all that stuff in the comments. Otherwise, today this has been Connect 3, which is just a really fancy version of tic-tac-toe, and I will see you tomorrow.